Yeah, it's going.
Oh, all right. Find the equation of the plane that contains the line, something given, and we're trying to find the plane that contains this line and passes through this point. See, writing down the equation that you're aiming for helps you to identify what you're missing and what you already have. So if you write down the plane equation, you have x naught, y naught, z naught, which is a point on the plane, and a comma b comma c, which is a normal vector. Which one do we already know? Yeah, because we can take it to be this one, right? That's something that we already know. Right? Okay, so that means we still need to figure out the normal vector to this plane. What do you think?
So just negative 1/2, negative 4/5, negative, or 2/3.
I think it's low. Not here.
Okay. So I think what you're trying to do is setting 0, 0, 0. But unfortunately, you can see that 0, 0, 0 is not a point on this plane. Because if you plug in 0, 0, 0, this gives you negative 1/2, and that gives you negative 4/5. But this equality doesn't hold. Yeah, so you can't do that. Actually, what you can do is you can plug in 1, 4, and 2. Right? Then do you see that 0 equal to 0 equals to 0?
Okay.
So what does that mean? I just plugged in 1, 4, 2 and got 0 equal to 0 equal to 0. What does that mean? That point is on the plane. What point? 1, comma 4, comma 2 is a point of the plane. Okay. So here's one possible way to do it. You have one point, you can identify one point passing through it, right? By setting 1, 4. So I know that 1, comma 4, comma 2 is on this plane. Can you find another point on this? No, not that plane. This is a line. Okay. 1, comma 4, comma 2 is on this line. Can you find another point on this line? Can you find another point on this line? How can we find another point?
2, 8, negative 4, or 4.
2. 2 minus 1 is 1/2. 8 minus 4 is 4/5. So, no, 1/2 is not equal to 4/5, so that can't be.
3, 9, and negative 5.
Okay, 3, you said 3, 9, negative 5. Let's see. 3 minus 1 over 2, that's 2 over 2, which is 1. Oh, that's good. Yeah. 9 minus 4 is 5, 5 over 5, which is 1, right? And 2 minus negative, oh no, that's not negative 5. What should you do?
Negative 1.
Negative 1, right?
So,
Yeah, negative 1. So 2 minus negative 1 gives you 3, 3 over 3 gives you 1, and you do have 1 equals to 1 equals to 1, right? So we know that 3, comma 9, comma negative 1 is another point on this line. And how did you get that? You just figured out numbers which will give you the outcome of 1, right? So you set this equal to 1 and try to find out the values of x and y and z that will give you 1, right? So that's how you found this one. In fact, you've stumbled upon this way to figure out the parametric form of this line. So if you're given a symmetric form of a line, often it's hard to figure out what the direction of this line is because of some sign changes. So you might think the direction of this line is 2, 5, 3, which is not true. Do you know the correct direction of this line? It's 2, 5, comma
3.
negative 3. Okay, now here's why. Let's try to change this into a parametric form. If you write it as x minus 1 over 2 equals to y minus 4 over 5, equals to 2 minus z over 3. Set it equals to t. Remember, how do you go from parametric to symmetric? You solve everything for t and set them equal to each other, right? The reverse process of going from a symmetric to parametric form is just setting everything equal to t and solving x, y, and z. So let's see. If you solve this, you get x equal to 2t plus 1, right? Y equal to 5 times t, and then you add 4, so it's 5t plus 4, right? And z would be, can you tell me z? Can anyone tell me z? Oh, okay. Negative z is equal to what?
3t.
3t
Minus 2.
minus 2. Therefore, z is equal to negative 3t plus 2. So now looking at this, and this, what's the direction of this line? 2, 5, negative 3. Right? 2, 5, negative 3. And if you plug in t equal to 0, you get 1, 4, 2, which was this one. If you plug in t equals to 1, you get 3, 9, negative 1, which is this one. Right? So that's what you're doing, really. Okay? If you wanted to find still another point, you would set t equals to 2, and you're going to get another point. Okay? All right. So by finding 3 points, we already know one method of getting this answer. What do? We find this vector, we find this vector, and then we take the cross product. That gives you the normal vector, and then that's it, right? We have the normal vector and the point, that's it. Okay? However, if you can read off the direction vector of this thing, you already have that 2, 5, negative 3 is one of the vectors that's parallel to the plane. So here's what I'm trying to say. See, you're trying to find a plane that contains this line that's described here, right? So the vector that's describing the direction of this line is actually parallel to this plane that we want, okay? So you already have one vector, and therefore to get the other vector in this plane, you just have to take any 2 points and subtract them. There will be another separate vector that's not parallel to the previous one. And if you have 2 vectors that's not pointing to the same direction, we can just take the cross product and get the normal vector, right? So let's do that. So I guess the shortest way to solve this is to first change it to this. And then next step would be to, from here, we know that 1, 4, 2 is a point on the plane. And here's another point on the plane. If you subtract the 2, you get a vector that's like apart from this direction of the line, right? So we get this vector, and then the direction of the line, this one has a direction 2, 5, negative 3. Then to find the normal vector, you just take the cross product. I, j, k, 0, negative 1, 5, 2, 5, negative 3, I, 3, minus 25, negative 22. And then from here, 0, minus 10, but the checkerboard aside makes it positive 10. K, 2k. So we know that negative 22, 10, 2 is the normal vector. And then going back and using this as our x naught, y naught, z naught, we have the final answer, which is, negative 22, x minus 1, and then plus 10, y minus 5, and then plus 2, z minus negative 3, equal to 0. That's the answer.